Hello, this is Dr. Yamada. In this video, I'm going to introduce the concept of one-way repeated measure ANOVA. Before I move forward, my assumption is that you have already watched and understood the three previous series of the concept of statistics level 1, which are independent t-test, dependent t-test, and one-way ANOVA. So, one-way repeated measures ANOVA is an inferential statistics that evaluates a statistical significance between two or more dependent groups. So the criteria to use one-way repeated measure ANOVA are exactly the same as the pair sample t-test. And to visualize the study design, when you use one-way repeated measure, recruited participants are not divided into three separate groups, but instead they go through all the conditions. Another situation where one-way repeated measure ANOVA is appropriate is you participants only go through one intervention, but they are measured more than 3 time points. Unlike independent and one-way ANOVA situation where participants were measured only once, in the case of paired sample t-test or one-way repeated measure case, participants are measured multiple times. Therefore, this type of research design is called within subject design or repeated measure design. So if everything is exactly the same with the paired sample t-test, why do you choose one-way repeated measure? So that's when you use more than 3 levels because paired sample t-test can only take 2 levels. Also, the strength and weakness of the study design is exactly the same as previously explained. The strength is you can remove individual difference, which I will show you how, and the weakness is there's order effect. Another question about why we use variance instead of the mean to obtain the difference between groups or condition is explained in the previous video. So I'm going to focus on the difference between one-way ANOVA and one-way repeated measure ANOVA. So I'm going to go through the quick review of one-way ANOVA. In one-way ANOVA, you compare the MS between treatment over MS within treatment. MS between treatment indicates the variance caused by the group difference, and the denominator MS within treatment is the variance caused by error and individual differences. So if there isn't any group differences, then the numerator will be smaller, but if there is a group difference, the numerator will be larger, therefore the F score will be larger. And what happens in one-way repeated measure design is that the MS within treatment can be further broken down. Specifically, you can separate individual difference. So MS within treatment consists of MS between subject and MS error. So MS between subject is the variance caused by the individual difference, and MS error is something else, which is called residual. So conceptually, here's what it looks like. So in one-way ANOVA, it's like cafe au lait. It's mixed with milk and coffee, and you can't separate them. However, in one-way repeated measures design, you can actually separate this. Basically, you order coffee and milk separately. Therefore, you can choose not to use milk, right? So you can remove individual difference. So the consequence is mathematically the numerator is going to be identical, but the denominator is not MS within treatment anymore. It is MS within treatment after removing the individual difference. So automatically the denominator will be smaller, especially for human subject research. The individual difference tend to be the largest source of variability. Therefore, it's statistically more powerful. So another visual aid to understand the difference between one-way ANOVA and one-way repeated measure ANOVA is the difference between these two versus difference between this and this. So how to calculate the degrees of freedom? The degrees of freedom for MS between treatment is K minus 1. Degrees of freedom for within treatment is capital N minus K. So if you have three conditions and you recruited 90 participants in one-way ANOVA case, then the degrees of freedom between treatment would be 3 minus 1 and therefore 2, and degrees of freedom for within treatment is 90 minus 3. One-way repeated measure N indicates the number of observations within each condition, and the capital N indicates the total observations. So if you recruit 30 participants, right, then even though you only have 30 participants, because you measure the same participants three times, you will have a total of 90 observations. So the calculation of degrees of freedom between treatment is exactly the same, within treatment is also exactly the same, but we don't need the degrees of freedom within treatment, right? What we want to calculate is the degrees of freedom error. So how do we do that? Because the degrees of freedom within treatment is made of between subject and error. So if you can calculate this, you can just remove this, right? From subtract this number from MS within treatment, which gives you MS error. So degrees of freedom between subject is lowercase n minus 1, which is 30 observations minus 1 in this specific example, therefore 29. So what you can do is you subtract between subject degrees of freedom from degrees of freedom within treatment, which gives you 58. The summary table of one-way repeated measure ANOVA could give you multiple source of mean square. However, what you have to choose is MS error. Depending on the summary table, you might have the MS between subject or even between within treatment. However, when you calculate the F score, make sure you choose the MS between treatment over MS error.